Welcome to Alphanumeric Tricks. In this video, we are going to see the topic Solution of Partial Differential Equations. In previous videos, we have seen that how to form a partial differential equation by eliminating arbitrary constants and arbitrary functions. Once we form a partial differential equation, we have to search for the solution for those equations. In this video, we are going to see the solution of partial differential equations. That is, in particularly what are all the solutions available in partial differential equations and how to find out those solutions. That is the method for finding the solutions. We will see it now. Before going to start with this topic, we will see what is a solution. The word solution exists everywhere. But in mathematics, when did you say that a term to be a solution? This is explained with this example, x squared minus 9 is equal to 0. You can write this equation to be x squared minus 3 squared is equal to 0. Using the formula a squared minus b squared is equal to a plus b into a minus b, we can write this equation to be x plus 3 into x minus 3 is equal to 0. But product of two terms is equal to 0, then at least one term should be equal to 0 or each term is equal to 0 individually. So we can this is the general rule. Using this rule, we will write this to be x plus 3 is equal to 0 and x minus 3 is equal to 0. So from this, when you taking plus 3 to right hand side, it becomes minus 3 and minus 3 to right hand side, it becomes plus 3. So you get the value of x will be equal to x is equal to minus 3 and x is equal to 3. When you substituting x is equal to minus 3 here, minus 3 the whole square is 9, minus 9 it becomes 0. This is satisfied. And also when you substituting x is equal to 3 here, 3 squared is 9, 9 minus 9 becomes 0. Then the point x is equal to 3 also satisfied in this equation. So we can say that x is equal to minus 3 and x is equal to 3 are solutions to this equation x squared minus 9 is equal to 0. From this, one can say that a solution to an equation means that the values which makes the equation true. That is, the values x is equal to minus 3 and x is equal to 3 makes the equation x squared minus 9 is equal to 0 true. So, from this we conclude that x is equal to minus 3 and x is equal to 3 are solutions to this equation x squared minus 9 is equal to 0. Now, we will see what is a solution of partial differential equation. This is explained by considering two different equations. Now, consider the equation z is equal to ax plus by and z is equal to x into f of x by y. These two equations are two different types of equations because this first equation contains two arbitrary constants a and b with two independent variables x and y, whereas in the second equation it contains a single arbitrary function f and the independent variables x and y. So these two equations are of different type because one contains arbitrary constants, another equation contains the function. That's why it is a different type of equations. Now you have to form a partial differential equation by eliminating arbitrary constants and the functions, and using those partial differential equation, we will see what is the solution of partial differential equation. Now consider this equation z is equal to ax plus by. How will you form a partial differential equation for that? You have to eliminate the arbitrary constants a and b. How many constants are there? Two constants. And how many independent variables? Two. Just x and y. So both are equal. So we can say that there is a resulting PDE of order 1. So we have to find out the first derivative p and q alone. Now you have to differentiate this equation partially with respect to x and y. When you differentiating z with respect to x, that is dou z by dou x, which is taken as p, that is standard notation, is equal to a into what is differentiation of x with respect to x, which is equal to 1. So plus differentiation of by with respect to x becomes constant. Why it is constant? Sorry, differentiation of by with respect to x becomes 0 because by is constant, because when you are differentiating with respect to x partially, the other term is taken as a other variable is taken as a constant, and constant differentiation becomes 0. Similarly, you have to differentiate this z partially with respect to y. Then that becomes dou z by dou y, which is taken as q, is equal to differentiation of ax with respect to y becomes 0 because x is constant here, plus b into differentiation of y with respect to y is 1. So we have q is equal to b only. Now the values a and b are readily available in this equations. When you are substituting these values in the given problem, then the constants will be eliminated. You get the PDE. That is z is equal to a is replaced by p into x plus q is replaced. B is replaced by q here into this y you have. So z is equal to px plus qy is the required partial differential equation after eliminating arbitrary constants a and b. Now consider this equation. Here you have how many arbitrary functions are there? Only one arbitrary functions. So what is the resulting PDE order? This first order. So here also we have to find out P and Q, that is enough. So differentiating z partially with respect to x and y now. What is differentiation of z with respect to x? Dou z by dou x, which is equal to P, is equal to, here you have to apply UV rule. Why we have to apply UV rule is x into f of x by y is there. That is product of two terms is there. Each is a function of x and we are differentiating with respect to x. That's why we have to use UV rule. What is UV rule then? First you have to keep the f of a, that is first for second term constant, differentiate the first term, plus keep the first term constant, differentiate the second term. Now we will do it now. That is x is the f of x by y is constant. So you write as it is, differentiation of x with respect to x becomes 1 plus x into differentiation of f of x by y with respect to x is dou f by dou x or f dashed. So f dashed into the that is the terms inside the function can be differentiated with respect to x and written in bracket. What is the constant term here in x by y? We are differentiating with respect to x. So which is constant? 1 by y is constant. So write as it is into differentiation of x with respect to x becomes 1. So differentiation of x by y with respect to x is 1 by y alone. Number that equation as 1. Now you have to differentiate z with respect to y, that is q, that is dou z by dou y is taken as q is equal to, when you are differentiating with respect to y, your x is constant, so write as it is into differentiation of f with respect to y is f dashed into the terms inside the function can be differentiated with respect to y and should be written in bracket. Here when you are differentiating x by y with respect to y, which is constant, x is constant, into differentiation of 1 by y with respect to y is minus 1 by y squared, that should be written in bracket. Why we have to use this bracket is, otherwise by mistake you consider this term as subtraction of two terms, that is x f dashed minus x by y squared you consider, which is wrong. So to avoid that confusion you have to write the differentiated term inside the bracket. Now using these two equations we have to eliminate the arbitrary function f now. Here directly when you divide p by q, the term f dashed will not get cancelled because previous problems we do that way, but here it is not possible because when additionally when f is there, so direct division is not possible. We have to do some more simplifications and then we have to eliminate the function f. From this, you take x into, what is x into minus x? You have minus x squared by y squared. You have to take that minus x squared by y squared to the left hand side. It becomes reciprocal. That is, y squared goes to the numerator of left hand side, and x squared goes to the denominator of the left hand side. So you have minus q y squared by x squared is equal to f dashed. So the value of f dashed is known to us here. Now we have to find out the value of f, then the function will be eliminated. And then how will you find out the value of f now? Think it of. Yes, you are right. From the given equation, z is equal to x into f of x by y, you can find out the value of f. That is, you have to take that z to the left hand side. So you have z by x is equal to f of x by y. That is the value of f. So f value and f dashed values are known to us. Substituting this equation where? As in equation 1, you can get the partial differential equation. We will do it now. Substituting in 1, p is equal to f of x by y is written as z by x plus x into 1 by y is x by y into f dashed value is minus q y squared by x squared. That should be written in bracket, and this z by x, that is f of x by y is z by x, that is taken to the left hand side. So you have p minus z by x is equal to x by y into minus q y squared by x squared. Now x get cancelled and y get cancelled, and what are the remaining term you have? P minus z by x is equal to minus qy by x. Now you have to take the LCM for this. Px minus z by x is the LCM, is equal to minus qy by x. Here both the denominator having x, so x get cancelled. So the remaining term you have is z is equal to px plus qy, which is the required partial differential equation. Now look at these two equations. Both are the same, but this is obtained from the two different equations. Z is equal to ax plus by and z is equal to x into f of x by y. So we can say that these two equations are solutions of this PDE. Z is equal to px plus qy, because from these equations only we obtain this partial differential equation. So which satisfies, we can say that which satisfies this, that the solution, these two solutions, z is equal to x plus by and z is equal to x into f of x by y, satisfies this PDE. Z is equal to px plus qy, and it is also a relationship between x and y. The given equation is a relationship between the independent variables and the dependent variables. Okay. So one can say that solution or integral of a partial differential equation is a relation between the independent variables and the dependent variables which satisfies the given PDE. Now, by considering the equation z is equal to x plus by and z is equal to x into f of x by y, we form a PDE. Z is equal to px plus qy. From using these, we can conclude some more statements. What is that conclusion is? Here, in this PDE, the z is equal to x into f of x by y is one solution, and z is equal to x plus by is another solution. So we get two different types of solutions for the same PDE. Okay, that conclusion we can make. What is our next conclusion is, here look at this first solution. This contains arbitrary constants. So a solution may contain arbitrary constants. Now consider this solution, z is equal to f of x by y. Here it contains the function f. So a solution of PDE consists of arbitrary functions as well. And also one more conclusion we can make. What is that is, both the solutions are the solutions of the same partial differential equations. That is because we can't say that the solution of partial differential equation is only it contains arbitrary constants, or the solution of PDE must contain only the arbitrary function. We can't say like that, because look at this, here itself we can get that a single PDE have two different types of equation. One contain arbitrary function and another solution contain arbitrary constants and the functions. We can make this conclusion using this result. Now we will see some of the definitions of solutions, that is, in partial differential equation have some solutions. We see what are the solutions. First one is complete integral or complete solution. Next is particular integral or particular solution, and another one is singular integral or singular solution. Now we will see one by one. What is complete integral? Look at this equation here. That is, from this PDE, we get the solution z is equal to x plus py. Look at this. Here, number of independent variables is 2. So, according to that, you have a number of arbitrary constants. So, if it is have like this, then we call this solution as a complete solution or complete integral. So, a solution contains as many arbitrary constants as there are independent variables. Then we call the solution to be a complete solution or complete integral. Next we will see particular integral. In the complete integral, suppose we are giving particular values to the arbitrary constants, then you get one solution. That solution is known as particular solution or particular integral. That is, a solution got by giving particular values to the arbitrary constants in a complete integral. Here only we have to give the particular values. Then you get the particular integral. Next we will see singular integral, that is the envelope of family of surfaces f of x, y, z, a, b is equal to 0. If it exists, then it is called a singular integral. This will not contain any arbitrary constants. So from complete integral only we have to find out the singular integral also, and this is the envelope of the family of surfaces that you should remember. Now we will see what is the method to find singular integral, or what is the procedure for finding singular integral. For that, consider the equation or partial differential equation f of x, y, az, p, q is equal to 0. Number that equation as 1. Now in the previous, now we will see that using the singular integral is obtained from the complete integral. So we have to write the complete integral for this equation 1. What is our complete integral? Here instead of according to the number of arbitrary constants, that is according to the number of independent variables, you can have the arbitrary constants, and it is free from the partial differential equations. So we can assume the complete integral is of the form phi of x, y, az, a, b is equal to 0, because it is having our independent variables x and y, and instead of the partial derivative p and q, you can have the arbitrary constants a and b. Then this is the, and also the function is a different one, because the solution we obtained is the different equation. That's why we are using the different function, not the same function f. Number that equation as 2. These a and b are arbitrary constants. And here, to find the singular integral, you have to differentiate this equation too, that is, differentiate the complete integral partially with respect to the arbitrary constant, not the independent variables. Then only the constants will be eliminated. Okay, so phi is differentiated with respect to a, you have dou phi by dou a is equal to 0, number that is 3, and then phi is differentiated with respect to b partially, so you get dou phi by dou b is equal to 0. Number that equation as 4. Now from 2, 3 and 4, we have to eliminate the arbitrary constants a and b. If it is exists, then we call it to be, that solution is the singular solution or singular integral. If it is not exist, when it is not possible is, that is, if suppose you, when you're differentiating these equations, phi is differentiated with respect to a and b, suppose you get an impossible result, in such case, and the elimination of a and b is not possible, that is, if it does not exist, in that case, the partial differential equation 1 does not contain any singular integral. And one thing you should remember, the geometrical representation of singular integral is the envelope of family of surfaces represented by the complete integral. That is, from the complete integral only we have to find out the singular integral, and which is the envelope of family of surfaces. You have to remember this also. Now we will find how to find the solution of general integral, that is the procedure for finding general integral. Here also, this is general integral also obtained by complete integral phi of x comma y comma z comma a comma b is equal to 0. Now, to find the general integral, you have to write one constant should be a function of another constant. That is, you have to write either a is equal to f of b or b is equal to f of a. In this video, we are using b is equal to f of a. Now, you have to substitute this term in complete integral. So you have phi of x comma y comma z comma a comma, instead of b you have to write f of a is equal to 0. Number that equation as 5. Now you have to differentiate this equation, that is this complete integral, with respect to the single arbitrary constant a, because after considering this b is equal to f of a, your constant will be reduced to single constant, and you have to differentiate this with respect to that single constant and try to eliminate the constant, that single constant. So differentiating the complete integral partially with respect to the arbitrary constant a, because we writing this is a function of a. Suppose you write a is equal to f of b, then the equation, that is this equation, contains b terms alone. In that case, you have to differentiate this complete integral with respect to b, and you have to eliminate that b. Okay. Now we will differentiate this. What is differentiation of phi with respect to a? Dou phi by dou a. But dou phi by dou a you have plus, but inside this function you have some other terms that instead of a, that is having a and b is a function of a we are considering. So function of a function rule we have to apply it. So phi is differentiated with respect to b first, and b is differentiated with respect to a partially. So that dou phi by dou b into dou b by dou a, you can write that way. Or what is dou b by dou a? Here b is considered as f of a. So when you differentiating this partially with respect to a, you get dou b by dou a, which is equal to f dash of a, that is written here, is equal to this 0. Number that equation as 6. Now using 5 and 6, you have to eliminate the single arbitrary constant a. If it exists, then we call this is the general integral of this equation 1, that is the partial differential equation f of x y z p q is equal to 0. We are considering now that equation, or that is a general solution of that equation. And one thing you should remember, when you're finding singular integral, you have to, that is the function, complete integral is a function of two arbitrary constants a and b. You have to differentiate the complete integral with respect to those arbitrary constants a and b, not the independent variables, and try to eliminate the arbitrary constants a and b. Okay, and you get the singular integral. Then that is, and to find the general integral, you have to write the one constant as a function of another one, and you have to eliminate that constant. That is, you have to differentiate the given complete integral with respect to that single constant, and you have to eliminate that constant. You can able to get the general integral. That you should remember. That's all for today's video. If you have any doubts in this, please provide in the comment section. Thanks for your time and thanks for watching. We will see in the next video. Thank you.